Hi again. I hope you're feeling recharged and energized after the lunch. Our next speakers are Tomasz Kolanko and Laszlo Molnar on Hitachi Energy New Acquisition CTF. A very warm welcome.
Hi. So we are from Hitachi Energy, and we are here to present you the walkthrough of our CTF. In case you tried and get stuck somewhere, or if you didn't know that it existed and you are curious how it looked, or if you forensics out the solution and you are curious about the originally intended path. So yeah, these are the contents. There will be a short introduction about who we are. There were a few Easter eggs inside, so we will mention those also. Then we will show you the solution, and there will be an announcement of the winner. So who we are? We are from Hitachi Energy. We are advancing the world energy system to be more sustainable, flexible, and secure. So we are developing all kinds of tools that helps electricity get to your homes from the power plants. We work for CSEC, which is short for Cybersecurity Assurance Center, and basically we are the ones who are performing penetration tests of the products of Hitachi Energy. My colleague here is Tomasz Kolanko. He is a cybersecurity analyst or pentester, and he has an OSCP certificate. And I'm Laszlo Molnar. It's pronounced without the Z, so just imagine it's not there and then you are pronouncing it correctly. I'm the chief cybersecurity analyst of the team, and I'm also certificate holder. And I will give the first part to Tomek.
Hey guys, as Laszlo mentioned, my name is Tomek. I work in Hitachi Energy as cybersecurity analyst. And my plan for today is to briefly talk about the cipher that our colleague created, Konrad. And then we'll move to the VM CTF. So a few days ago, Confidence posted that string on, I believe, all of social media, so Facebook, LinkedIn, and stuff like that. And I wanted to show you my solution, which I did pretty lazy and pretty fast, as I've used mostly online tools for that. So the first step was to convert the values, decimal values, to the ASCII, which basically gave us paste bin address. And after entering that address, we get the string. So as you may noticed or not, if you tried that, well, basically this is base 64 encoded string. So after decoding that part, we would get another message. Konrad prepared, and it says, here we have an encrypted secret, ever cracked block. 128 boys indeed tried to crack it, but no one succeeded before. And we've got one string, which is hexadecimal, I believe. Yeah. And then the second part, which suggests, the text suggested that's the secret. So one thing I've noticed, that capital letters shows that we are working with a algorithm with 128-bit key encryption. And it is ECB mode. So I guess I was right as I solved that. So for now, we will stick only to the second part, which for you may also look like base 64, but it was actually base 32. So after decoding, we got totally random string, which for me looked like totally URL, but with some extra steps. So I reversed order of the characters in that, which gave me this thing. And well, if you know about Caesar cipher, this is quite one of the most basic ciphers that ever were created. It basically means that we are shifting orders in the alphabet. And this example shows rod 13, which is shift 13, which was the solution for that part. And I also used an online tool for decoding, so I didn't have to write any code at all for that one. And that gave me another paste bin. here are the contents, and yeah, I'm smarty now. So for me, it looked like hash, and I've checked that it was actually MD5 hash, but you could actually Google that string, and it would already give you the key. So not much possibilities apart from that. So yeah, we had to take a step back, and now we should be able to decode the message using key we already found. And I also used online decoder for that. So that was the first flag. So for all of you that found that one, good job, and thanks, Konrad. It was amazing. I had a lot of fun doing that. I could also do it on my mobile phone, as most of you probably did near our stand. So yeah, thanks a lot. And now we've got the second part, which was VM, virtual machine. Type of this virtual machine was boot to root, and some backstory, if you haven't read that on our Discord. We basically bought a company as a Hitachi Energy, and we wanted you to perform 10 penetration tests on it. Technological stack we've used for the web part was Flask, jQuery, MongoDB, and Nginx. And ultimate goal, the intended one at least, was to exploit the virtual machine starting from the web part and finishing as a root while finding all the flags. So for those who did forensics, also good job. But that was not really intended solution. I mean, we expected that, but whatever. Yeah, so if you manage to download the virtual machine and find the IP address, you would be greeted with this HTTP service on port 80. And basically, if you're a penetration tester or you do CTFs, from here you would already be running some unauthorized scans, like any scans at all, yeah, directory ones. But that really was not the point. You could all just view the source of this page, and you would already see that we've got some more information and hints what to do next. So we got email address for flag submission. We've got some lazy admin email address, and also there is a scripts.js file that if we enter and just inspect what's the stuff in there, you could see that those endpoints are used in the web app. And this one in particular might be interesting, because if you tried to enter it, it would give you 404, which means one of two things. Either it is not implemented properly, or you don't have access to it. But you're not aware of that at first, so just keep that information in your mind. And then we have to go back to the login attempt. And here was the second Easter egg. If you tried to log in with our flag submission email, you would get a flag. So good job to all of you that found it. And if we tried to register just using some example data, we would get redirected to user dashboard. And from here, you can see that there are not much functionalities you can work with. You could view the configuration, and it would give you like some XML file with basically name of the services, some ports, some IP addresses, but you couldn't interact much using this file, this endpoint. So there was also the second thing, the password change. And if you tried to enter some data here and intercept that request with, for example, burp, you could see that we are actually sending email address, old password, and a new password. And here's the funny thing, that according to RFC 9225 that came on April 1st this year, as software defects considered harmful, they wrote that in point 4. Best current practices, and here I'm referring to point 3, which is basically saying that when implementing specifications that are broken by design, it is recommended to aggregate multiple smaller bugs into one larger bug. Well, yeah, this will be easier to document rather than having a lot of hard-to-track inconsequential bugs. There will be only a few easy to recognize significant bugs. So if you don't know, RFC are basically internet standard for technical specifications. And I did exactly as they said. So I've implemented, well, not working properly, like functionality. So first of all, email was not verified properly. Old password was also not verified properly. And there were no password requirements at all. So that would lead us to quite severe authorization bypass. And, well, if we entered our email address for the admin, we also would get quite misleading status, because it says 200 OK, but then in the body we could see that it is an error, but it was all just misleading. So because we also get success, and after that we would get redirected to user panel, but now as an admin. And while keeping the thing which I said in the very beginning, that we have endpoint that we could check only as admins, we can now try to enter that, and we would be greeted with another panel and another flag, of course. And basically from here we could specify some ports for the services we already viewed configuration for. Then we could update the configuration, which would generate us an output, which is, of course, XML file. And we could upload the configuration to the devices. And if we hit intercept in burp, in that case, we could see that we are sending XML file. And what comes to your mind when performing a penetration test and seeing XML files? Ideas, maybe? Oh, I've already shown that, sorry. So basically, well, you could try to implement, sorry, not implement, send XXE payload. And in that case, the most popular one is using system entity and trying to read contents of etc past WD, which, as you guess, already, if you tried the CTF, that would give you the answer for that. And if you zoom that in, you would get the flag, you would get 2 users, and some, well, ideas what to do next. Because basically, this is something I have to say, that XXE can be used to print contents of the files. Usernames can be found in etc past WD. And the next step would be to search for private key, which is not the default ID RSA, but we also left the hint for that in authorized keys or in vim info. So yeah, you could basically just get a file name from just sending another XXE payload. Well, basically, you could also read contents of private key. And that, to be honest, concludes the web part. Because now you're able to log into SSH as CTF user. And if you tried that, you'd get a shell. So yeah, thanks.
Yeah, so after you use that private key to log into the system, you are authenticated as CTF user. Now, CTF user doesn't have a whole lot of things that he can do. So, of course, we want to escalate privileges there. There is a flag at the login printed in the message of the day as you SSH in. And looking around, you will quickly notice that the most suspicious route for a successful privilege escalation is using the setuid or setgid privileges, file privileges. So in case someone wouldn't know, these are some legitimate Linux features which allow lower privileged user to execute binaries as higher privileged users, which have valid business requirement behind them. For example, to change the password, you need to modify the etc shadow file, and you can only do that as root. So So for example, the passvd executable works like this. It is, for security reasons, it's only working for executable files, binary files, not for scripts. And so in the engineer user's home folder, we can find an executable called program that has the SUID and GUID flags set. We also find next to this executable the source code, which you can see on the right. So this is basically the simplest possible setuid file you can imagine. It just checks the effective user ID and group ID, and then just sets that as the real user ID, the effective user ID, and the saved set user ID, and then just executes ID, which is a benign program, so what could go wrong? It doesn't even have a lot of functionalities. So the issue here is that we notice is that ID is not run with an absolute path. So we instantly think about path hijacking, for which we want to create or add a new folder to the beginning of the path, and then add the executable named the same way into this folder. And after we do that, the ID command will execute this binary file that we just placed there. So on the bottom, we can see how this happens. So we see the original. OK, I don't see my laser. Anyway, we see the original path. Then we see where is the ID executable. And then we export the TMP folder at the beginning of the path. We copy the bin-bash executable to TMP named ID. And after this, we see that already the system finds this binary if we execute which ID. And after executing the SUID executable, we can see that we escalated privileges. Now we can run ID from the original path with full path, and then we can see that we are engineer. As engineer, in the home folder, you find a note, a simple text file that the engineer group has read access to. And you see there a little bit of like scenario background to understand what is happening here. So basically, the root and the engineer were trying to figure out a way to run their own SUID programs, but in a way that they can run scripts as well. And the engineer was developing this program to make a kind of proof of concept about this to the root, and the root was also developing his own solution, about which he writes a little bit here. The final solution is a Python file in opt called mysuid, and what it does is basically it is called by cron tab, and every minute it executes a file named cmd in the home folder of engineer. This file has one line of command in it and one line of signature. It's signed by the root's private key, so with RSA signature. So it's a very safe way to execute any kind of code that they want after the root signs that, OK, this is a code that you can execute. But for performance reasons, the root decided that he will not hash with some kind of safe, secure hash the contents of the command. He will hash it with CRC32, which, if you know about wired equivalent privacy, then you know that CRC is not very safe. So yeah, this is the mysuid Python file. at least the important part of it. So basically, we can see what happens. So first, the read command, the function down is called. It opens the CMD text file from the engineer's home folder. It verifies the signature. If the verification fails, then it writes invalid signature. And if it's successful, then it will execute the first line, which is the command. And the actual signature verification is up, which basically calculates the CRC code of the command, and then it calculates basically decrypts the signature, the RSA signature, and it checks that the two values are the same. So the main problem here is that CRC32 is an error detecting function. So the purpose of it is to detect if there was a transmission error when you were downloading some big file, or if there is damage to a CD or DVD file. And it is not a secure hash function, so there were no efforts made to avoid any collision. And even though RSA is a safe encryption method, if we encrypt the weak hash and we can find a collision to that hash, then the encryption will be the same if the hash is the same. So to show how bad CRC is, if you can modify 4 bytes in a file to any value of your choosing, then you can decide what you want the CRC32 hash of that file to be. So there is on this link a detailed description of the mathematics behind that, and there is also implementation in multiple languages. But what we need to understand here is that basically if there is some part of the message that we can edit, then we can just decide what CRC32 hash we need to get, and we don't even need to brute force it. Although brute forcing is also a very valid possibility. So what we want to do is to get on the first line of the CMD file something like here, so in this hex dump, so like, let's say, copying bin bash to tmp bash, giving ownership to the root, and adding the suid bit, since we already know that it's very easy to exploit that to privilege escalation. And then we can just run the bin bash file, and we will have the higher privileges. So for this, first we need to calculate the original CRC32 code so that we know what hash we want to set. For this, we don't even need to code. We can just reuse the code from the mysuid.py from the root. And on the top right, we can see these lines are copy-pasted from the Python file, except the last print line, which prints out the CRC32 hash of the original command, which was just ID again. I think this time with a full path. And then we have to create a new command that we want to execute. So the text from the previous hex dump is there. At the end, we add a comment and 4 A's. We will modify those 4 bytes to match the CRC32 hash. Yeah, and then we just need to download the Python script from the earlier link. And we can just run that with Python. The first parameter is the name of the new command file. The second parameter is the position of the modifiable bytes, so the first A, which is the 71st byte in this case. And finally, the last parameter is the desired CRC hash. And then after we run this Python code, we can just copy the RSA signature to the second line. and then wait for cron tab to execute the roots Python script, and then we get the suid bin bash in TMP. Are there any questions? No questions. Okay. So the first one who solved the challenge is Jakub. So we would like to ask you to come to the stage.
Oh, this one.
He gave permission to us to do this beforehand, so we are not in violation of GDPR or anything. So, congratulations. Thank you very much.
Thanks a lot.
Right, and for those who sent us partial solutions, we would ask you to come to our stand later, and you will also receive prizes. And yeah, so see you there. Thank you.
Thanks a lot.
Thank you guys for the presentations. Congratulations to Jakub.